Okay, hi you guys. So for today's lesson, what I'm going to ask you is does this point lie on the given line? Or I may ask you, does this point satisfy the equation? Or another question they may ask is, does xy make the equation true? Okay, so here's pretty much what I'm asking you. So we have this line, right, which is linear. And if I ask you, does 2, 1 lie on this line, right? So if I give you a graph, you guys can clearly just look at it and say, okay, 2, 1, the answer would be yes, right? What if I said 1, negative 2? Does this point lie on the line? And again, you could just graph it and say, obviously this one would be no, right? It does not land on my line, okay? Now down here, we still have another line, but I'm giving you the equation of the line, right? So if I ask you, does this coordinate lie on my line? I may ask you, does it make the equation true, right? So just remember, what does a coordinate represent? So this coordinate is telling me x is 1 and y is 3. Now, if you look at the actual graph, it is going to lie on the line. But for today, I'm not always going to give you a graph. So algebraically, how would we do this? So here's my equation, right? It's y equals 2x plus 1. So I'm going to plug 3 in for y and 1 in for x. And then I'm going to just simplify, use my order of operations, and what do you see? Sorry, I'm running out of room. What do you notice on both sides? Is that true? Yes, it is true. Okay, so when you plug in your coordinate into the equation, right? If both sides are equal to each other, then that means that coordinate will lie on my line. Okay, so that's the main focus for today. So on this side, notice there's no graphs. So the first question saying, does 4, negative 5 satisfy the equation? And all that means is when I plug in my x and my y, so negative 5 equals 2 times my x, do both sides equal each other? And I think we can agree no. So the answer is no. And what that means is if you graph this line, right, and you can try it on Desmos, 4, negative 5 will not be on that line. So that's what it means to satisfy the equation or make the equation true. All right, let's try another one. And you guys can just watch me. So does 9, 3 make this equation true? So this is my x and this is my y. So I'm going to plug it in. So y is 3. Does 3 equal 3 times my x minus 5? So I'm going to use PEMDAS, that's all. It's almost like you're checking an equation. You guys are pros at this now. So do these equal each other? Nope. So that means if you graph that line, which eventually you will learn how to do it without Desmos, that point will not be on that line. That's what that's asking. All right, let's try one more together, and then you guys can start your classwork. So does this point satisfy the given equation? So notice, by the way, this equation is not in y equals mx plus b form. So for some students, they would prefer to put it into y equals mx plus b form. Okay, I'm going to do that anyway because that's part of your classwork today. I think we could benefit from practicing a little more with that from yesterday. But I'm going to show you how you can plug it in as is. You're going to get the same answer. 5 times x would be 5 times 3 minus 3 times y is 5 should equal 2. So this is 15 minus 15 should equal 2. It doesn't, right? So this is no. That coordinate does not satisfy the equation. All right. So just for practice, I'm going to go over again how to put this equation into y form, right? Which is actually y equals mx plus b form. We're going to talk a lot more about that next week. So that means I have to get y alone. So I can't touch this. I have to get rid of my bow, which is my 5x. To move it, I'm going to subtract it. What am I bringing down? I am not bringing down a 3y. I'm bringing down a negative 3y. Right? And then remember, try to get in the hang of doing this now. The x is first. I should put the x first here. Right? You can't combine them because 2 doesn't have an x. What's my last step to get y alone? Divide everything by negative 3. So y equals 5 over 3x minus 2/3. Okay? So you are going to practice putting things into y form today as well. But if they're asking you, does this point satisfy the equation, you can plug in the x and the y as is. That's fine. Okay? And then after you show all your work, you need to figure out, are both of these sides equal? If it's not, the answer is no, which means it doesn't lie on the line. If the answer is yes, that means it would lie on the line. Okay, so feel free to watch this again if I went a little fast, but you guys have plenty of classwork to work on. All right, have a great day.